Everyone. So our topic for today is link budget, budget calculations for fiber optic systems. So idea ng link budget class is, for example, this one. Okay. We have here sa left portion the transmitter. So natin ang transmitter circuit. Just before sa fiber optic cable, ang light source, which is either an LED or a laser, and then connectors. So the same gamon sa receivers, ato gyapon ato ang receiver circuit and photodiode, no, the photo detector, and ang connectors output also. Now somewhere in between would be our fiber optic cable, and kung taas ra ang distance from transmitter to receiver compared sa isa ka roll of fiber optic cable, well, need ta mag-perform splicing. So sa kaning visual, splice will happen somewhere in between. Kung mas taas pa ana, daghan nga splices ang mahitabo. So kaning image sa bottom na part is what we call the link budget, okay? Or the power budget. So sa left portion, ano siya ang atong transmitter, transmitting output, measured initially in milliwatts, and pwede na convert into dB. Ano siya dire. And then ang pinaka-bottom na portion is sa left side, I mean sa right side, is ang sensitivity sa receiver. This one is your sensitivity. So pinakasagad na gid na siguro, no? Let's just say if pag-abot sa receiver, the power nga ma-receive sa receiver is exactly the measure, no, na specified sa sensitivity. Pero if taas-taas pa, that's what we call the margin. So example lang, that's transmitter output, let's just say is 10 dB, no? Example lang siya. And then ang sensitivity sa atong receiver is specified siya negative 5 dB, no? Kasi ma-measure pa lang yan, negative 5 dB na light. Right. Now, what if after performing calculation, na-obtain na itong number is, let's say, negative 3 dB, so na-obtain margin, so that the margin is negative 2 dB or 2 dB. Basically, yan na lang ang idea sa link budget. It's just a simple na addition subtraction. Kay almost everything here is measured in dB. Now, we all know, sa dB gani, calculations is either plus or minus again. No? So plus kung amplification or gain, and minus kung losses. Yeah, let's go mag-multiply divide kung convert from dB to milliwatt or milliwatt to dB. Yan. So notice here, sa atong kuan, no? Malagi tunong man siguro ning visual sa taas ug sa silong. No? Every time maybe a connector happens or even a splice, ay pag-lower down sa dB. So each of these would add to the losses. Kada isa ani nila, yung mga connector, mga splice, dungan na sa subtract na losses. So not only that, notice also nga from one connection to another, no, from connector to connector or connector to splice, the kanaog pud ang atong signal. So we all know that fiber optic cables also exhibit losses due to distance. So kanang mga losses, technically ato lagi na lang i-summarize na or i-add and i-minus lang sa transmitted na power. mabilin would be the power that will be received by the receiver or the photo detector. We have here an example of a simple link budget na problem. To determine the power received in dB and in watts for a 20-kilometer fiber optic link with the following parameters. So the LED output power is 30 milliwatts. Each fiber optical roll is 5 kilometer with loss of 0.5 dB per kilometer. If you remember, makita niya siya sa specification sheet. Moments yung ganyan pinakauna na makita sa specs sa fiber optic cable. Connector losses, source interface loss, detector interface loss, cable bending losses are negligible. Okay, so kaning example is the simple one, no? Ayun na siya. Ang isa ka example dito. I-solve later. Diba? Another example, which ato i-solve lang later. No? So aside sa the usual given, no? Output power, losses sa connectors, and ang loss per kilometer of fiber optic cable, ang isa ka addition dire is dire ay 1, 2, 3, 4, 5. Okay, so wala din ng mga example. Na particular example of this one. So this another. Okay. Another siya dire. Sabi lang ko wala siya dire. Pero na i-solve on. No? But before that, so i-share po na screen sa other na device. So these are specification sheets nga. This is a specification sheet na ito na encounter last time. This is our specs for our fiber optic cable. So dito na naka-specified. Notice here, this is the attenuation or the losses due to distance measured in dB per kilometer. So for this wavelength of light, 1310, I think mo ni pinaka-common na wavelength na sa light nga gamiton. No? So pila na siya. Pilalihan ko na lang. In terms of hertz, 1310 nano. 228 giga, 228 gigahertz or terahertz. Anyway, okay lang. So for this wavelength of light, manihang attenuation per kilometer in terms of dB. Ang buko specs dire for a fiber optic transceiver, no, receiver transmitter. So siya ka example. So muna itong makita sa transmitter nga part. So this will contain the light source, either LED or laser. And in the receiver nga part, this will contain the detector, photodiode or phototransistor. Naman siguro dire yung sa siya nga technology ang gigamit. No? For the transmitter section, dire The transmitter section incorporates 1 310. 1 310 nga gapon niya gamit nga light source. Fabry, Pearl, laser. So una siya nga technology ang gigamit. For the receiver section uses MOVPE grown planar SED pin photodetector. So, pin diode. Such thing as pin diode for low dark current and excellent responsivity. Of course, all of these are important. Pero ato ta dito sa portion kung asa na magamit na to sa atong link budget calculation. Diba? So, transmitter optical characteristics. So, pinakauna gyapon, output optical power, 9 micrometers SMF. For this type of i-use na cable, the minimum power output is negative 9.5 dBm. Okay, dBm. The maximum is negative 3 dBm gyapon. So, ang maximum nila for any cable is negative 3 dBm. Minimum is parehas siya for multimode. Multimode man 62.5 diameter lugar ni siya nga micrometer, multimode fiber. Ang isa is 50. Pareha lang din sila minimum, maximum power output. So, muna siya. Makita nato sa specs gyapon ang power output sa atong light source. Sa photodetector na po dire, receiver sensitivity is negative 20 dBm. Yeah. So kung mabalik ta sa atong, i-memorize lang nato nino or i-take note lang, negative 3 and negative 20. So i-take note lang nato na siya para ibutan nato sa atong example later. So these are actual receiver sensitivity and power output of receivers and transmitters respectively. Napunta specs dili for connectors. So this is what a fiber optic connector looks like. Daghan mas lang mga different forms, pero isa sa mga common pod. It's compatible for pareho sila standard man gid ay ang 62.5 or 50 nga multimode and 9 micrometer nga single mode. Sa iyahang loss dire. Adela insertion loss. So nata dire for single mode 0.2 dB typical insertion loss. So these are actual values if we compare it to our example earlier. So of course medyo realistic din atong example. So very practical na example right here. So compare sa atong specs earlier, di lang sa example, sa ito lang ang specifications. For the transmitter, negative 3 dBm. And sensitivity is negative 20. Negative 20. So those are examples. And for each splice and connector, na siya loss 0.2, di ba? So for each of these na 0.2 dB nga loss per connector. So these numbers are based on the specs that we have. Okay, based na to sa atong kanina example, we have a output power 30 milliwatts, so i-convert pa ni to dBm. We have each fiber optical roll is 5 kilometers only. No? So 5 kilometers lang isa ka roll with losses of 0.5 dB per kilometer. Compare na to sa atong Corning. As lossy ning ato example, 0.3 naman ang sa Corning. So 0.5 na siya. Connector loss is 2 dB each. Source interface loss is 1.9. So dako siya, no? Detector interface is 2.1. So cable bending losses are negligible as of this example. So ani magamit ang connector losses in this example. So notice that ang distance from the transmitter and the receiver is 20 kilometers. So how many rolls of fiber optic cable do we need? Pila ka roll for the 20 kilometer? Four. That's 5 times 4, right? So we need 4. Okay. So equate niya siya. Mag-use ng 4 rolls. Okay. So if natin 4 rolls of fiber optic cable, how many connectors do we need? I-splice na ito na yung 1 roll to another, or a fiber optic cable sa isa ka roll to the fiber optic cable sa next na roll. So ilang connector atong gamiton? For Japan. Three. Yeah, ano pa sa silong, no? 3 connectors. So 3, because, well, ang other end sa first na roll is connected man sa transmitter, and ang next na end, or ang pinaka-end, I mean, is connected sa receiver. So only 3 nga connectors needed. So i-multiply lang natin ng connector to 2 dB per connector times 3 connectors is 6 dB. I-add natin sa tanan, 6 plus 1.9 plus 2.1. Ang 1.9 is loss sa interface. Ang 2.1 is loss sa source. I mean, ang 2.1 is a source. No, ang 1.9 is a source. Ang 2.1 is a detector. No? So fiber loss due to length is, if 0.5 dB siya, 0.5 dB per kilometer, and we have 20 kilometers, so 0.5 times 20, so 10 dB ang attenuation. So this is the attenuation due to length. Okay. So 20 kilometers times 0.5 dB per kilometer is 10 kilometers. So the total loss is 20 dB. So minus ko na ito diretso sa 30 milliwatt. Hindi pa. Kaya 30 milliwatt is i-convert na ito to dBm. So we have 2 solutions right here. Isa is magamit ang pure na dB, which is pwede lagi DI, no? If pure dB atong gamiton, meaning i-convert na to si 30 milliwatts to dB. No? So let's lang, 10 log 30 milliwatt. 10 log 30 times 10 to the negative 3. Okay? So 30 milliwatt divided by 1 watt. It's 30 milliwatts. So the answer is negative 15.23. So si negative 15.23, una siya ang atong i-minus o negative 35.23. Sorry, negative 20. So negative 15.23 minus 20 is negative 35.23. Okay? Tama ba ba? So si 15 is nakuha na to by converting 30 milliwatts to dB. Not dBm yet, but dB. So negative 15.23 dB minus 20 is negative 35.23 dB. So ano na siya ang ma-receive sa atong receiver, negative 35.23 dB of power. Now, to know if pila na siya ka actual milliwatts, negative 35.23, ato ba we convert to watts. So i-anti-log lang nato ni. First, i-divide og 10. So negative 35.23 divided by 10. We all know nga, ang formula ani is 1 man, di ba? 10 log power in dB. So, sorry. Power in watts. Okay. Power in watts. Ano yung power in dB? So, power in dB divided by 10, then anti-log. Anti-log is 10 to the power of something. Negative 35.23 divided by 10 is negative 3.523. 10 to the power of that. And 10 to the power of 3.5. 0.003. 0003 times 1 watt is 0.3 milliwatts. Wala naman kayo niyo. Pwede naman wala. Para naman eh. So, 0.3 milliwatts. Wala siya ang ma-receive or ma-detect sa itong detector. Okay. Now, how about for the alternative na solution? Okay. So, ang atong given na 30 milliwatt, convert nato to dBm. So, 10 log 30 milli divided by 1 milli. Calculator ninyo na siya, 10 log 30 is 14.77 dBm. So, sa lugar na, sir, ang given man is, given nga losses is 20 dB man. Diba? So, remember, pwede lang pang-add or minus actually ang mga dB and dBm. Pero, because of plaka nyo to dBm, ang output ato is dBm na, no? Hindi na dB. So, no, this the same sa itong example here. So, ang 14.77 dBm source, subtract na to 20 dB, answer will be in terms of dBm. Okay? Decibel. So, president, so 14.77 minus 20 is negative 5.23 dBm, which is compared sa atong transceiver, okay ra. Kato, ang sensitivity sa atong actual na transceiver kanina, as a specification sheet niya is negative 20 dBm. So, kanina negative 5 dBm, okay pa ni. Layo pa ni sa tinuod. So, kung ato ning i-graph dito sa atong kanisya, ang ma-receive lugar dito is negative 5.23. Negative 5.23 dBm. 23 dBm. Whereas ang sensitivity is negative 20 dBm. Ang transmitter output is 14.77 dBm ito, di ba? So, layo pa, no? Layo pa. 5.23. Ma-detect pa na siya sa atong receiver. So, we'll not stop there. Ato pa i-convert ang atong dBm to watts, balik. No? So, I hope kabalo na mo sa pag-convert from power to dBm or power to dB. And from either dBm or dB, convert back to watts. So, kung kay dBm man sa sinugdanan, after dividing by 10, after dividing by 10 and then atong i-anti-log, no, 10 to the power of the answer, i-multiply pa og 1 milliwatt. Dire. 1 milliwatt. So, ang atong 0.3 times 1 milliwatt is 0.3 milliwatts, which mo coincide sa atong answer kanina. Okay? Mas intuitive siguro for us kung gamiton lang ang in terms of dB. Straightforward lang siya. Pero convenient ang dBm because ang ato magong mga specified na losses sa sheets nato sa atong specs kay in terms of dBm ang good. So mas mag-make sense ni siya. Anyway, flexible man ang mga units, whether ang nakabutang sa specs is dB or dBm. Kung ipa-minus na to sila sa given source, okay ra, wala problema. For as long as, again ha, ang conventional delay ng warning is if mag-use nga itawag dBm, make sure nga ang last na answer is in terms of dBm. Just like this one. dBm itong igamit sa input. Palag dB ang loss, the final answer should be in dBm. Okay. I hope that's clear. Sige daw. Sige, on your own daw. Try to solve this example. I'm sure kaya ninyo nila.